ourselves to the two-dimensional motion of the curve. So that is the thing that we will be basically studying. Now in this the 2D curve, so we see that we need to create a plane first, and the plane can be created by, for example, we can have the x-axis and y-axis. Let's take these two as our the reference line, sorry, and the plane that these two reference lines produce, this particular plane will be termed as plane of motion. So in case of plane of motion, essentially we have that in case of the plane of motion, we see that the thing is this, that we need to consider that the plane of motion is basically the plane in which the motion of the particle that will basically take place. So this is the plane in which the particle will move around. So we term this as to be the plane of motion. We call this as the plane of motion, right? So this is our plane of motion. Now in case of this plane of motion, we have another thing. So the plane of motion is the plane, we can say, in which the particle is moving around, correct? Now we have the next thing, which is known as the trajectory of the particle. We say it is the trajectory or path followed by the particle. Path followed by the particle. So that we call it to be as the trajectory. Again, if you have any question, feel free to ask me at any point of time. So let's say this is our fixed point O, and the motion, we can define the curve. It can be any curve sort of thing like this. So this curve will be our the trajectory, and in this curve basically we will put a sense of motion of the particle. Maybe the particle is moving from, say, from the point A to point B. So naturally, if this is its starting point A and this is the starting point B, so this will be your sense of the motion. If it travels from point B to point A, obviously the sense needs to be reversed. So this is termed as the sense of motion of the particle. Now if I want to describe this motion of the particle along this curved path, so we require certain coordinate system in which we need to describe this motion. What are the coordinate systems that are required for the description of the curvilinear motion, plane curvilinear motion? So we can say coordinate reference frames required to study the curvilinear motion, plane curvilinear motion. So we will be using, number one, we will be using the XY coordinate system. So that one we will be going to use. This is the XY coordinate system, the coordinate system that we have shown here. So that is the first type of the coordinate that we are going to use. The second type of the coordinate that we will be going to use will be termed as the normal tangent coordinate system, NT coordinate system. And the third category that we are going to use for this description of the curvilinear motion is the r theta coordinate system. So this is the r theta coordinate system. So these are the three coordinate systems that we are going to employ to study the motion of this particle. So first we will start with the description of the XY coordinate system. So motion in XY plane, motion in XY coordinate system, so to say, motion in XY coordinate system. So in this case, the figure that I have drawn in the top, is actually the corresponding figure where the x-axis and y-axis are two fixed straight lines. They intersect at a fixed point, which are inertial. So this constitutes what is called as the inertial reference frame. So this constitutes what is termed as the inertial reference frame. Now here, suppose I consider the particle at any arbitrary point of time. Say this is the initial position of the particle. The particle is moving along this green curved path in this sense. So the point A being the the initial position of the particle, and after, say that means here the particle is here at time t equal to 0, and after some arbitrary time, let us suppose that the particle reaches to this position. So if I call that arbitrary point as P, the position of the particle as P, then we can describe this position with reference to this xy coordinate system by obviously the two coordinates x and y. And you can very easily see that when I am describing this with these two coordinates, x will be some function of time as well as y will be some function of time. So it is it is actually the parametric description. You see the time being the parameter. This is called the parametric description of the particle motion, and t is the time which is the parameter. So if we eliminate this t from these two equations, we will be ultimately getting an equation. Either it can be expressed as y as a function of x, or it can be expressed as function of x comma y comma some constant is equal to 0. So either we can express it in this form or we can express it in this form. In both the cases, what they geometrically represent, they geometrically represent the equation of the path followed by the particle. So each of these actually represents what? This represents the path of the motion, path or trajectory of the particle. Correct? Trajectory of the particle. So if I know this description, that means I know I see that here that the coordinate of this, the two coordinates of this point, right, it changes as the particle occupies different positions on the curve during its journey. So as it travels along this path, the coordinates x and y will be changing continuously. At least one of them must change. Other may remain constant, but at least one of them must change. So if I have this description, then it is pretty obvious. Let's take the case of see as the particle is moving, the x coordinate and y coordinate both are changing. So what we can do, we can describe the motion of this particle in two coordinate systems. So one is the motion in x direction. So we have to simultaneously consider these two directions. So we call this as motion in x direction. So when we say motion in x direction, our first level of information is of course the displacement of the particle, because you see here, if I see from here, that if this is the particle position at any point of time, then obviously if I join the line from here to here, this will represent the position vector r bar of the particle. So let me show it here in some way. Say suppose we consider this is our origin, right? And we see that after time t, the particle is at point P. So at that point P, we find that this is my position vector. So this represents your position of the particle. So this is where P is. This is where your P is, whose coordinates at that point of time is say x and y. So this is our position vector at that point. I say this position vector as r bar, and it is pretty obvious that r bar is also a function of time. So I can write from here that r bar, that means the position vector of the particle at any point of time, can be represented as, you see here, we can write it as xi bar plus yj cap. xi cap plus yj cap, where I cap and j cap are the unit vectors along the x-axis and y-axis respectively. So this is its position vector, correct? Now, as we see from here, therefore, that as the particle changes its position along the curve, if we see, this is the say the curve, and let us suppose that this is our position vector at time t as measured from this origin. So this is your position vector, and let's suppose that this point represents my origin, correct? So after time t, the particle moves to say this position, correct? And at that new position, what will be the position vector? Obviously, the position vector will be now this one. So this will be the position vector after time, say, let us consider this is point P at time t, and let us suppose that this is the point P dash at time t plus delta t. So I can say this is my position vector at time t r bar t, and that was my position vector. That was my position vector, which I call it as r bar t plus delta t. So it is obvious that during this time delta t, the particle actually has this displacement. So this is our displacement. So this displacement vector that I will be getting from here, we can write it as delta r bar. And how I can write this delta r bar? Now it is pretty obvious that delta r bar is r bar at t plus delta t minus it is r bar at time t. Clear? So this will be my displacement. Yes. So this will be my displacement. I have. Sorry.
Has a recording on me.
Yes, I have forgotten to press the recording button. Sorry. From this point of time, I will be recording my class. Sorry. I totally forgot to press the recording button. Anyway, so I think the first part is already being recorded at your end. So there will not be any problem, and I will take your copy of the recording as well, because my first part recording is not there. So please forward me the recording that you are making to me as well for today's class.
Okay, sir.
Okay, thank you. So we see that this is my the displacement during the time that is taking place delta t. So my average displacement will be, again, going by the same procedure that we followed in our earlier class. It will be delta r bar divided by delta t, and that is being given by how much? We can say that it is r bar t plus delta t minus this will be r bar t minus this will be r bar t divided by the delta t. Correct? So this is the scenario. Now this average the rate of displacement, I can take now this delta t to be very, very small and make that delta t to be tending to 0. So I say this is limit delta t tends to 0, and I have this one limit delta t tends to 0, and therefore the above equation that represents we should not write it in motion in x direction. This is what we are generally describing. So I erase this caption from here. So this is the general description of the motion that I am doing, not the x direction motion. So you see, this one will be, ultimately we can write it in this form, in calculus form. We can write it as delta dr bar dt, or we can say this to be written as r bar dot. So we see from here, by definition, we know that the rate of change of displacement is termed as the velocity. So I can therefore say that v bar will be equal to dr bar dt. This is the vectorial description, or we can say that this will be equal to r bar dot. Correct? So that will be our first expression for the velocity. Now it is pretty obvious from here, this is pretty obvious from here, that if I describe this the position vector in this manner, that it is xi plus yj, then it is apparent from here that v bar will be given by, we can use this equation to write, this will be ddt of the xi x of t I cap plus it will be y of t j cap. So I have both these time variations. So if I further differentiate this expression, so it becomes dx dt, which I am writing in short as x dot I cap, because this is a constant vector fixed in direction, sense and magnitude, we don't have any differentiation. Otherwise, we need to differentiate this unit vector also, and we will soon see how we can handle the unit vector differentiation. But at least in the description of the xy coordinate system, we don't require it. So we find from here that this will be x dot I cap plus we see that it will become y dot j cap. So I see therefore that the velocity vector is now having two components. One is this x dot I cap and another is y dot j cap. So the component along the x direction is x dot and component along the y direction we call it, we have y dot. So ultimately we can write this expression in this way. So this is Vx I cap plus Vy j cap, where obviously this Vx and Vy, what they represent? Now they represent the x component, x and y components of velocity, x component and y component of velocity vector, of the velocity vector that we are getting. So this is the velocity vector that we are seeing. Now once I describe that this is the velocity vector, we can find out from here what is the magnitude of the velocity, or so to say what is termed as the speed of the particle. So we can now write that the magnitude of the velocity, we can say that magnitude of the velocity vector, often termed as the speed of the particle, is, we can write it like that. And what will be this? Now the magnitude of the velocity vector can be written in this manner. So this is your magnitude of the velocity vector, which is v, and which we can write it to be equal to, obviously this is x dot square plus y dot square. This is the magnitude, and the angle that this velocity vector will be making with the x-axis, if I call that angle
Sir, hello.
equal to phi, then it is obvious. Yeah, hello.
Sir, আপনার আমার ভয়েসে গ্লিচ করছে হবে।
আমার ভয়েসটা কি হচ্ছে বলো তো
এবার ঠিক আছে,
ঠিক করুন স্যার।
ঠিক আছে
গ্লিচ
এবার।
করছিল স্যার, গ্লিচ মানে কেটে কেটে যাচ্ছে। এখন ঠিক আছে স্যার।
আচ্ছা।
রিপিট করে দেন একবার।
আচ্ছা আচ্ছা আচ্ছা।
হ্যালো
হ্যালো স্যার, আপনার মনে নেট কানেকশন কিছু
হ্যালো স্যার।
হ্যাঁ হ্যাঁ
হ্যালো
দাঁড়া নেটের প্রবলেম হচ্ছে স্যার।
Is it okay now? Hello hello।
স্যার মাঝখানে
বন্ধ হয়ে গিয়েছিল।
মাঝখানে কি হয়েছিল বলো তো? একটা কি একটা হলো দেখলাম, কি হয়েছিল?
কথা বন্ধ হয়ে গিয়েছিল, মানে আর কি আওয়াজ পাচ্ছিলাম না কোনো।
আচ্ছা, যদি কখনো হয় সেটা আমাকে একটুখানি জানিও। হ্যাঁ
হ্যাঁ, এই ম্যাগনিটিউড অফ ভিটা আপনি বলেছেন, তারপর তো
magnitude of v, okay. So you see the magnitude of v, এবার শোনা যাচ্ছে তো?
ইয়েস স্যার।
Okay, so magnitude of the velocity vector v bar, which is this is v, that is equal to square root of x dot square plus y dot square, and the angle that this velocity vector is making.
স্যার প্রেজেন্টেশন বন্ধ হয়ে গেছে।
প্রেজেন্টেশন বন্ধ হয়ে গেছে? এই কি ব্যাপার হচ্ছে? কি ব্যাপার হচ্ছে এটা? আমি তো কিছু বন্ধ করিনি।
স্যার আপনি একবার দেখুন।
স্যার একবার অফ করে অন করুন স্যার।
হ্যাঁ না না আমি অফ করি মানে স্টপ করে আমি আরেকবার অন করছি
ইয়েস ইয়েস
ওকে না এখন
এখন ভিজিবল আছে
হ্যাঁ স্যার ঠিক আছে
আমি জানি না কিছু টেকনিক্যাল প্রবলেম হচ্ছে হয়তো so you see the vector is making an angle phi with respect to the x-axis and this angle phi is being given by phi equals tan inverse of the y dot divided by x dot. Or in other words, we can say that the speed of the particle v, the speed of the particle is equal to root over of dx dt whole square plus we can say this is dy dt whole square because we know that x dot is equal to dx dt and y dot is equal to dy dt. Correct? So this is the expression for the speed of the particle. Correct? Is it okay? Is it okay?
yes sir
yes sir yes sir
Thank you. Now we can look at this problem. So this much is pretty clear. So we need to give some more interpretation to these equations. For that, what we do, let us consider the curve. And we see that this is our initial position vector, and suppose that this was your final position vector. So we see that this is the thing, and we noted that the displacement vector is this much. So this is your displacement vector. So we see from here that if this is r bar, and if this is r bar t plus delta t, then this is the displacement vector which we called it as dr bar, right? We turned it as to be dr bar. So this is dr bar. Now what is the magnitude of this vector dr bar? So it is pretty obvious that if this is a and this is b, then this represents the magnitude, right? And if I make this delta t tending to 0, correct? So if I make this delta t tending to 0, this dr bar will have two components. Actually, if you see the expression for dr bar, what will be the expression for dr bar? Obviously, dr bar expression will be dx I cap plus dy j cap. What is dx and dy? Suppose if I consider this is our reference frame, say this is x-axis and y-axis. If this is our reference frame, and let's say we call this as P and P dash, sorry, not A and B, call them as P and P dash. So if I write this as P and this is P dash, then we noted that this is the position of point P and this is the position of point P dash. So point P is having the coordinates x and y, point P dash is having the coordinates x plus delta x, comma y plus delta y as the particle changes its position during the time delta t. So naturally, if I join these two lines, that means if I call this is P and P dash, what is this line segment? Correct. If I join this line segment here, the line segment will be something like this. And this line segment is essentially consisting of, if I draw a small right angle triangle here, so you see this will be the essentially this thing that we will be getting. So if I drop these two perpendiculars from here, obviously this represents the change in the x coordinate that the particle is having during time delta t, which is delta x. So this will be delta x, and this one will be the change in the y coordinate that the particle will suffer during the time delta t. So we can call it as delta y. So if I call this as delta r, right, the magnitude, this delta r, then the magnitude delta r is basically equal to how much? That is equal to root over delta x square plus delta y square. Now if I suppose that this time gap is very small, that means from here to here the time, that is delta t is limit tending to 0, then obviously these distances will be actually the differential form. So I can say from here that the dr, so as delta t tends to 0, I can write as delta t tends to 0, this delta r, now it becomes dr, which is the magnitude of this change, and this magnitude change will be given by what? This is dx square plus dy square. Now this dx square plus dy square, we can write this thing to be equal to, you see, this we can say the magnitude of this delta r bar, correct? The magnitude of this delta r bar or d.
স্যার আপনার কিন্তু ভয়েসটা গেস করছেন
হ্যালো স্যার।
স্যার স্যার অডিবল
of this dr bar is hello
হ্যালো স্যার।
স্যার স্যার
hello
স্যার আপনার ভয়েসটা প্লিজ
ভয়েস গ্লিচ
না
করছে।
নেটওয়ার্কের প্রবলেমের জন্য এরকম হচ্ছে।
নেটওয়ার্ক প্রবলেমের জন্য হচ্ছে, কি হচ্ছে বলো তো ভয়েসে?
এটি পুরোই স্টপ হয়ে যাচ্ছে।
আচ্ছা এখন কি দেখা যাচ্ছে? আচ্ছা এখন কি দেখা যাচ্ছে?
হ্যাঁ
ও আবার একটা নেটওয়ার্ক প্রবলেম হচ্ছে না? ব্যাপার হচ্ছে, দাঁড়াও দেখি, ইগনোর করি, দেখি এখন কি শোনা যাচ্ছে ঠিকঠাক?
হ্যাঁ শোনা যাচ্ছে এখন ঠিক আছে স্যার।
এখন শোনা যাচ্ছে, আচ্ছা ঠিক আছে, ওকে আচ্ছা। Anyway, so we see from here that now is it okay?
Yes
স্যার ইয়েস স্যার।
Okay. So we see that this, the magnitude of this, we can write it as the magnitude of this dr bar, correct? We can write this as this magnitude. We can write it to be equal to ds. Right? This ds is actually the, the arc length that the particle is traversing along this curved path. So this is the arc length. We call this arc length as ds. This is the arc length that we are getting. So this is ds. So ds is basically given by this expression, where you see the this one, that means when I make this delta t tends to 0 and when I make these two coordinates vanishingly small, I get this as ds, where s will be termed as the arc length. That means as you are bringing these 2 points closer and closer together, you see that if you bring these 2 points from here and here, then this, suppose if these are the 2 points on the curve and this is the arc length that we are getting between these 2 points, as we make this b closer to point A, what I will find as is that this arc length will be approximately becomes equal to this chord length, correct? So essentially when I am taking the finite distance, this is the finite gap. So essentially
স্যার
essentially
কি বললেন অ্যাপ্রক্সিমেটলি?
yes বলো,
হ্যাঁ কি বললেন অ্যাপ্রক্সিমেটলি, মানে গ্লিচ
Hello?
হয়ে গেছিল।
হ্যালো হ্যালো
হ্যালো স্যার।
হ্যাঁ
হ্যালো স্যার আমি অডিবল টু ইউ
হ্যাঁ কি হয়েছে বল, যে কোনো একজন বল, যে কোনো একজন, সবাই মিলে না বলে একজন বল।
হ্যাঁ মানে অনির্বাণ জিজ্ঞাসা করছে যে ওই অ্যাপ্রক্সিমেট ব্যাপারটা আরেকটু রিপিট করুন।
হ্যাঁ ঠিক আছে, সেটা কিন্তু মানে আমার মনে হয় একজন কেউ কথা বলে না, তো বোধহয় মাইকের খুব একটা সমস্যা হচ্ছে, নেটওয়ার্ক ইস্যু হতে পারে। মানে আসলে দুপুরবেলার ক্লাসে এটা একটা প্রবলেম, সকালের ক্লাসে কিন্তু এ ধরনের কিছু হয় না। মানে আজকেই সকালে আমি ক্লাস নিয়েছি প্রায় 1.5 ঘন্টা, দেয়ার ওয়াজ নো প্রবলেম। বিকেলের দিকে বা দুপুরের দিকে হলে একটা হতে পারে, দাঁড়াও, একটা হতে পারে আমার পাখার জন্য হয়তো আওয়াজের ট্র্যাকিং হচ্ছে। It may be যে পাখা is also producing some problem. Now is it my voice is clear to you without
Yes,
any?
sir, yes, sir.
Yes,
Yes, sir, audible.
your voice is clear.
Okay. আচ্ছা আমি আসছি ম্যাগনিটিউডের পার্টটাতে। আমি বলছি যেটা, সাপোজ ইফ ইউ কনসিডার, অ্যাকচুয়ালি কি হচ্ছে না, ইফ আই টেক দিস 2 পয়েন্টস A and B very close, say if we consider a curve, and we are taking 2 points on the belonging to this curve. let's say this is point A and let's say this is point B. Now when I am saying this displacement vector, actually I am referring to this chord, correct? This is the chord that I am referring to. And we have, this is your arc length. Now this arc and chord, they will come, because there is a difference between this chord and the arc. Normally the chord length is less than the arc length, correct? Because the straight line is the minimum distance between the 2 points. So naturally this arc length will be more than this chord. But if you bring this B closer to point A, when this will occur? Now when you are making this delta t tending to 0. As you are making delta t tending to 0, the point B will be very much close to point A, and this arc length will actually coincide. This arc and the tangent, they will get coincided with each other. Actually in mathematics, we can write it something this way: limit B tends to A when this is occurring as delta t tends to 0. The arc length AB and the chord length AB, this ratio between these two is equal to 1. So that is the situation, and this consideration will take place when this delta t, rather this time gap, is tending towards 0. So as a result, we can say at the limiting situation, this will actually represent the differential arc length between these 2 points A and B, and that differential distance between the 2 points A and B is being represented by this called ds, and ds is being given by this quantity called root over dx square plus dy square. So that is our ds. Now here you know that you cannot ignore dx square and dy square. That means they are not so small that you can neglect the square of the differentials. Actually the higher order terms beyond it will be neglected, but dx square and dy square cannot be neglected. So from here we can see that if we can take this dx square common, and then we can derive from here the differential equation that ds dx is basically equal to root over of 1 plus dy dx whole square, correct? So it can be represented in this manner. So if I just remember this basic the differential relationship between the 2 points on a curve at a close proximity, we can come and revisit our velocity equation here. So what is that thing you are getting from here? You are getting that your speed v is basically equal to, you see here, the speed v, we can write that the speed v, we can say that it is equal to d dt of root over, we can say, sorry, it's not d dt, I have taken this dt common from here. So I can write it is something like this. I can say this is 1 by dt. I can say that it will be dx square plus dy whole square. So this is the thing that I am getting. So I can say from here that this being equal to ds, since this is equal to ds, ultimately I get from here that the speed of the particle v, this becomes equal to ds dt. So this is alternative description of the speed of the particle in plane curvilinear motion. So we find that we can find the speed by differentiating the arc length of the curve. Arc length means what? Arc length means if I have this curve like that, and if I say call this as our starting point and this as our finishing point, then basically the total distance along the curved path will be your arc length. That means someone can measure by means of the measuring tape or something like that, the distance along this curve. So if I say this, I call this as my arc length. This is the total arc length S. How to find out the total arc length S for this curve? Now you need to integrate this equation. That means you need to come to this equation and say that your total arc length SBA between A and B, SASB, we can write it in this manner, will be equal to integration from XA to XB. It will be root over 1 plus dy dx whole square dx. So if we are given the relationship of this curve, if you know the equation of this curve in this format, y is equal to f of x, we can find out this in this manner. Sometimes you may not be able to find this very simply, or in this case rather by finding the expressing this equation in this form, it would be say much easier for you. Suppose a case where you find the inverse function of it. So if you have the equation of the curved path given by this format, you need to change your integration and can write it from say ya to yb, correct? It will be ya to yb, then it will be root over 1 plus dx dy whole square dy. So you need to integrate this relationship in order to find out the total arc length traveled by the particle. But if you are saying you are trying to get the instantaneous position, say this is the instantaneous position of the particle, and you are trying to calculate the velocity of the particle, obviously then it will be, the speed will be given by v equal to ds dt. So this is giving me 50% information of the velocity vector, because we know that vector quantity is something which should be having its magnitude, as well as it should be having the direction, as well as it should be having the sense. So we have found in that way the 50% information of it. The remaining 50%, I mean to say the direction and sense, we have to fix up now. Now for doing this, again we come to this description. We see that this is making an angle with respect to the x-axis, and this is the angle it makes. Let's say this angle is phi. So how much will be this angle from here? From this right angled triangle, it is pretty obvious that tan phi becomes equal to delta y by delta x. Now if you make delta t tends to 0, then this relationship ultimately takes the form, if delta t tends to 0, this relationship ultimately takes the form that it will be tan phi equal to dy by dx. And what is this physically represent? As we have just now told, that at the limiting position, the arc will get coincided with the tangent, with the chord, and what will happen to the chord? The chord will ultimately become tangent, because as point B travels along the point A, as your delta t tends to 0, we see that it will be gradually coming to this, and at the extreme situation, this chord will become tangential to this curved path. So therefore, in the limiting case, we find that our velocity vector will become tangential to this curve at that point. So this tangent basically serves the purpose of our direction. So what I mean to say is something like this. Suppose if this is your curve and you are here in this position, so your velocity vector will be along this tangent that will be drawn to this curve at this point. So this tangent specifies the direction of the velocity. So velocity will be either directed along this or along this. So its direction will be along the tangent. Correct? How I get it? Because we see that dy dx basically represents the slope of the tangent drawn to the curved path at some arbitrary point. So I find from here that the velocity will be always along the tangential. So the next remaining portion is its sense. in which direction, in which sense the velocity will be. Direction I am getting, this is the direction. But what is the sense? Now for that you need to remember that the sense of the velocity vector will be incommensurate with the sense of motion of the particle. Because at the beginning we saw, we considered that this was your initial position of the particle, let's say A, and this was your final position of the particle, let's say B. So your particle is moving along the curved path from A to B. So quite naturally you can understand that when the particle is at some arbitrary point P, its velocity will be directed along this tangent and its sense will be incommensurate with your sense of motion. In this case, your sense will be given by this. So this is representing your sense. If the sense of motion gets reversed, obviously you can understand that this arrow will also get reversed and it will be like that then. So you see, I have therefore resolved the entire issue. I therefore say that now, since I say that I have resolved this issue, I can therefore say that this is my speed of the particle and the speed and the velocity vector of the particle will be directed along the tangential direction to this path. So you can understand from here the description that we have given, the short description that we have given as the particle moves along a curved path from some point P to point P dash during the differential time gap delta t. We find that from here we can get the velocity expression. And in doing so, you can see you need to simultaneously consider the x component of motion and the y component of motion. Why it is so? Because as the particle changes its position on the path as shown here, the particle is suffering the change in the x coordinate as well as change in the y coordinate. That means when the particle is having this displacement is having these two components, one along the x direction and other along the y direction. So quite clearly from here, if I differentiate, then the velocity also will have two components, one along the x direction and other along the y direction. Now once we understand this basic thing that for a curved path, curvilinear motion, the velocity will be directed tangential to the curved path followed by the particle, we are now in a position to find out the acceleration vector. So we can say now the acceleration, the acceleration of the particle in the xy coordinate system. So we say that it is acceleration in xy system. So how we can do it? Now we can do it from the information of the velocity vector. Because we know that we have just now seen that the velocity vector is being given by, say it is x dot I cap plus y dot j cap.
স্যার আপনার ভয়েসটা খুবই কেটে যাচ্ছে কিন্তু
আবার
ঠিকই আছে
স্যার ভয়েস কাটছে আপনার
একই
হ্যাঁ, এবার ঠিকই আছে।
ঠিকই আছে মনে হয়, ঠিকই আছে।
না কারো ক্ষেত্রে বোধহয় প্রবলেম হচ্ছে আর কি।
তাহলে আমার এন্ড থেকে গেলে কিছু অসুবিধা আছে?
একবার লিভ করে জয়েন কর কিংশু।
আবার
না 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 আপনারটা
না না আমি
না সবাই মিলে কথা বলো না, তাহলে মুশকিল হবে। যে কোনো একজন বলো, যার ভয়েস কাটছে, যার কাছে আমার ভয়েস কাটছে সে একবার নতুন করে জয়েন করো।
হ্যাঁ হ্যাঁ হ্যাঁ
ইয়েস স্যার ইয়েস
স্যার কন্টিনিউ করুন স্যার।
So yes, so we see that your velocity, the description is being given by this x dot I cap plus y dot j cap. We can write this as say dx dt I cap plus we have this is dy dt j cap. So this is the expression we got. Now from this expression we will be able to find out the acceleration vector. So how this acceleration vector will be calculated? Now this will be, this is dv bar dt. We know already, we have introduced this concept in our previous class. So ultimately we can say that it will be dx dot dt I cap. Again we do not differentiate I, plus it will be dy dot dt, we have j cap. So ultimately we can write this as x double dot I cap plus y double dot j cap, or else we can write it like d2x dt2 I cap plus it will be say d2y dt2 j cap. So this is how you can see from here that I can find out my acceleration expression. So if I find this acceleration expression, I can compare it that I can write this as ax I cap plus ay j cap. So if I collect these terms, ax represents how much? What is ax? Ax is dvx dt, right? Because vx is x dot and this is vy, this y dot is vy. So I can say this is ax is equal to dvx dt and ay is equal to dvy dt. So that is one expression. Another expression is that it will be d2x dt2 and this one will be d2y dt2, correct? So basically you need
Yes sir.
So you need to find out the second derivative of these two with respect to time. Now there is another alternative expression which is not very obvious from here. For that we have to attack this one and write it in this manner that it will be dvx dx into, we can say this is dx dt. And since you know that dx dt is vx, so ultimately we can write this to be equal to vx into dvx dx. And in a similar way, I can write this as vy into dvy dy. So these three are therefore, the alternative expressions for accelerations in the xy coordinate description. So therefore, the first type of problems here in the xy coordinate system, it is pretty simple. If you are given, so you have here the first type of problem. In the first type, problem of first kind, we can say problem of first kind, in which we will be given, the information regarding your x and y. That means you will be given expressions for x of t as well as you will be given expressions for y is equal to, y is equal to, we will be given the expression for y is equal to y of t. And from there we need to find out the corresponding velocity and acceleration. That is pretty simple. Just you need to differentiate them and you need to get your result. Let's see just for our this thing convenience. Let's take a problem. I just take up a problem from here. So let's quickly move on to the So this is our the chapter. I just increase this this where, oh my god, কোথায় গেল রে ভাই?
জুম করবেন?
হ্যাঁ, একটু বড় করব এটা।
কন্ট্রোল প্লাস করতে পারেন।
হ্যালো,
একটু লেখাটাকে বড় করা যাচ্ছে হয় খুঁজে পেতে। এনিওয়ে, আই থিংক ইট ইজ।
হ্যাঁ স্যার, এমনি দেখা যাচ্ছে।
ইজ ইট ভিজিবল ফ্রম ইওর এন্ড?
ইয়েস স্যার, ইয়েস স্যার,
দেখা যাচ্ছে। ওকে, ফাইন। এমনি দেখা গেলেই এমনি দেখা গেলেই।
Sir, your voice is glitching, I guess.
স্যার আপনি কিছু কি বলছেন?
প্রপার 60 রিডার আইডি ফর অফ ইউ হ্যাভ ইওর বুক। হ্যাঁ, তোমার কে গো? তুমি কে? হ্যালো হ্যালো,
মানে আপনি কি বলছেন স্যার? ওটা বোঝা যাচ্ছিল না, মানে হুট করে আটকে গেছিল।
ও আচ্ছা আচ্ছা আচ্ছা,
করছিল আর কি স্যার।
এখন ঠিক আছে, এখন বোঝা যাচ্ছে?
হ্যাঁ
হ্যাঁ,
হ্যাঁ
হ্যাঁ,
হ্যাঁ 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 হ্যাঁ।
আজকে মনে হচ্ছে বিকেলের দিকে দুপুরের দিকে এরকম নেটের সমস্যা হয়। So let's take the
Fresh
problem
local.
number. Problem number 2/62. What it says? It says that a particle which moves with curvilinear motion has coordinates in millimeters which vary with time in seconds according to the relation x is equal to 2t square minus 4t and y is equal to 3t square minus t cube by 3. So what we do, we just very quickly write that it is being given for us, that x is equal to x is equal to
T
you know
cube.
yeah,
minus 4t.
x equal to 2t square minus 4t.
2t square, sorry.
So x is equal to, yes, 2t square minus 4t, where x is in millimeter, x is in mm, and t is in seconds. T is in seconds, correct? And y is equal to, at the same time, you know, the y is being given equal to 3t square minus t cube by 3. So y is equal to 3t square minus t cube by 3. So these two relations are being given to us. So here also y is in millimeter and t is in seconds. So what is the question they are asking? The question they are asking is that it is given that determine the magnitudes of the velocity and acceleration vector and the angles which these vectors make with the x-axis when t is equal to 2 seconds. So it is very pretty simple. What you need to do, you need to find out from here the velocity, right? Vx you need to find out, Vy you need to find out. I'm not doing it because it's very simple for you. And from the description of Vx, you can find out this. I am discussing problem number 2/62. 2/62. So of the 7th edition. So any problem number comes here, it actually refers to the 7th edition of the book. So the ax you can find it from here, and similarly if you differentiate further, you will be getting the expression for ay. So Vx will be described here as a function of time, and Ax will be also described as a function of time. Similarly, Vy is also function of time, as well as Ay is also function of time. So once you get from here, you can find out the magnitude of the velocity as function of time, v of t, which will be equal to root over Vx square plus Vy square. So you can find out the expression for the speed, and similarly, and similarly you can find out the angle that these two velocities components are making with the x-axis. Call that angle as tan theta. Theta. Then tan theta is being given by Vy by Vx. That tan theta will also be function of time. Now it is being said that you need to find out this for, you know, at what time. It is saying that at t equal to 2 seconds, you need to find out the magnitudes of this velocity vector as well as acceleration and the angle. So for the first part, you see here, if you put t equal to 2 seconds in your expression, you will be able to find out the magnitude of the velocity. Here also, if you put t equal to 2 seconds in your expression, you will be able to find out theta. Exactly in a similar manner, from Vx you have found Ax, from Vy you have found Ay. So now you can find out the magnitude of acceleration A, which will be, you know, given by, that is equal to root over of Ax square plus Ay square, and that will be also as a magnitude of time, as a function of time. And then you can put into this expression A of 2. That means at t equal to 2 seconds, how much will be your magnitude for acceleration in millimeter per second square. Your answer here will be, you know, the expression for velocity, I mean to say the speed, its unit should be in millimeter per second, and in this case the unit should be in millimeter per second square. Why? Because x is being given to be in millimeter and t is being given to be in seconds. So you need to give these units, otherwise your marks will be deducted heavily. and if you do not mention the units properly. And you can find out the accelerations from here, and also you can find out the angle that this acceleration vector is making with the x-axis. So you can find out your tan phi, that will be equal to your ay by ax. So again, at t equal to 2 seconds, if you put into this expression, corresponding angle phi will be easily determined. So this is one type of problem. This is the simplest type of problem where you are given the x and y this way. And then we may have a inverse type of problem. For example, just the next sum. What it says is that the problem number 2 by 63, it says that the x coordinate of a particle in curvilinear motion is given by x equal to 2t cube minus 3t. So the next problem, what it says is something like this. What it says is something like this. Let's say it is problem number 2 by 63. I'm just giving you two specification problems. You need to solve some of the problems from this chapter, so that you get some control of it. So x is equal to 2t cube minus 3t. So you can write your x is being given by 2t cube minus 3t. This expression is being given, and it is mentioned that x is in feet and t is in seconds. Don't worry, we will not be having any feet and second problem in semester or in class test, because all our units will be in SI system. So these feet, all these things will be changed. In this case, okay, let's say this is in feet and t is in seconds. And the y component of acceleration is being provided. Oh my God. So in the x direction, they have given x. But in the y direction, because as I told you, the curvilinear motion is a simultaneous description of x component and y component. So for curvilinear motion in the y direction, instead of giving me the y as some function like this, here the specification of acceleration is provided. And what is that acceleration? It is equal to 4t. So ay is being given equal to 4t, where again I think it will be in feet per second square.
Yes.
So yes, if the now since they have given ay equal to 4t, now they say that if the particle has y components y equal to 0 and y dot equal to 4 feet per second when t equal to 0, because I told you that any higher order specification is bound to have additional information. What is that additional information? That additional information is information at the initial situation. So what it says, now at t equal to 0, your y is being given to be equal to 0, and your y dot has been given to be equal to 4 feet per second. So this is 4 feet per second. So they may be having plus sign or minus sign. Plus means it is positive in the positive y direction, minus means it is in the negative y direction. So all these things are pretty clear to you. So what I have been asked is to find out the magnitudes of the velocity v and acceleration when t equal to 2 seconds. So it is almost like a previous problem. But in the previous problem, it was very simple because your initial information were given in the displacement form. But in this case, it is being given in the mixed form. You may have next higher order problem where both these relations, both this information will be given in the acceleration level. Here, one is being given in the displacement level, another is being given in the acceleration level. In the next problem, you may have both these to be given in the acceleration level. So this part we have already discussed, how to find out Vx, and from there how to find out Ax. We have already discussed here in this problem, correct? So follow that same procedure to find out Vx and Ax. But for this one, what you need to do? Pretty simple. We have already discussed it in our discussion in terms of our rectilinear motion. So you see, consider that in that way, although the motion is not rectilinear. Anyway, we can consider this, and therefore we can write it in this manner, that it is dvy dt, and change your variable in this level So dv by dt, then integrate it from say 4 feet per second to any arbitrary velocity level, say vy. So I integrate it between these two. So it will be integration from t equal to 0 to at any time t, it will be 40. So this is dvy, that will be equal to 40 dt. So it means what? It means from here that I will be getting from here that it will be vy, which is the velocity of the particle at any time t, minus 4 feet per second should be equal to 2t square in the limit, from 0 to t. So it means that it becomes equal to 2t square. So from here we can say that we have vy equal to 4 plus 2t square. And again, if you integrate this relationship, since this is equal to dy dt, so you need to do successive integration. So if you integrate it again, dy, integration dy, this time at t equal to 0, y is being given to be 0, and at t equal to t, let's say y is equal to y. So it should be equal to integration from 0 to t, it will be 2t square plus 40 dt. Correct? So it means from here, right? 40, correct. So it will be 40, sorry, thank you. So we can see from here that it will be y, that it is equal to 2 by 3 t cube, correct, plus 40. So you see, y as a function of time, y as a function of time is how much I have got. So this is the entire expression for y as a function of t. And you remember your x was being given, x was being given as, x was being given as how much? X was being given as 2t cube minus 3t. So together you have the relation. So x of t is 2t cube minus 3t. So if you eliminate now the time from these two equations, you will be straight away getting the relationship as y as a function of x, which physically represents the equation of the trajectory of your particle. So you see, therefore it is pretty simple. Just apply your previous knowledge to get this. One special type of problems in this category are the problems in projectile motion. Problems of projectile motion. And what is a projectile kind of thing? If you recall your earlier, study of your higher secondary physics, you know that what is basically the projectile motion. Now here in this case we will be having a horizontal ground, and in this horizontal ground we have some ball here, and that ball is being projected with a velocity say u naught, making an angle theta naught here with the x direction, and the entire motion takes place against the gravity. So it is the gravity field in which the motion is taking place. So in this case, as you know, the particle will travel, and it will travel along this curved path, and this path we can prove it that this is basically a parabola. How that can be done? Now that is pretty simple. In this case, if I assume that if this along this direction I consider it to be the x-axis, and this direction I consider to be the y-axis. So here, if we suppose that there is no sidewise force from here, no sidewise force, we can see, since there is no sidewise force, my equations of motion are prescribed in the x direction, that ax is equal to 0 because there is no force acting along the x direction, and ay is equal to minus g, together with the initial information, and that initial information is what? At time t equal to 0, you are having x and y both are equal to 0, and you see the x dot is basically equal to u0 cos theta 0, and y dot is equal to u0 sine theta 0. Both are plus because this velocity is having the components along the positive x and positive y directions. So it is, yes.
স্যার এখানে বললেন এরোডাইনামিক ড্র্যাগ আর ওই কার্ভেচার আর
ওইগুলো নেগলেক্ট করছি, ওইগুলো বললাম যে ওগুলো নেই। In absence of that only I am considering. If of course there is some, the sidewise force like this, it's acting, it's producing some acceleration, then you cannot write this and you need to write some expression for acceleration if it is known to you. Correct? And in this case also the motion of the air resistance, everything is neglected, and we can take the expression for like this. That is the general classical the problems of projectile. So now your results are very simple. You need to find out from here with this additional information, you need to find out from here the last thing, that x as a function of time. From here also you need to find y as a function of time. Now from these two descriptions, simultaneous descriptions, as you have found the variation of the x coordinates and the variation of y coordinate with respect to time, finally if you can eliminate this time t from here, you will be able to set a relationship between y and x. For example, in this case, what will be the relationship? It will be x tan theta 0 minus gx square by 2u0 square cos square theta 0. ঠিক লিখলাম তো? So that will be your expression for your the equation of your path. And see, from here you can see that ultimately this equation can be written as y equals ax minus bx square. So it describes a parabola, and the parabola will look like this. And here a couple of things are important. For example, this distance we call it as the range r. So range is the distance along the plane of projection where the projectile comes and hits it. So some of the cases you may have the situation something like this. You may have an inclined plane, sort of plane like that. You may have an inclined plane here, and you may have a the point from where you project certain projectile with some velocity, say u naught, making an angle. Let's say this is theta naught with the plane, and this plane is having an angle, say let's say this angle is phi. So now your projectile will be something like this. So it will come and hits the plane over here. So in that case, then this will be your range. So how to do this equation? Again, it is simple. If you look that this is your acceleration due to gravity, this is your acceleration due to gravity, we can decompose this acceleration into two components, one along this direction and another along this direction. Correct? So if I make this as our x-axis and perpendicular to this direction as our y-axis, then obviously you see that this line is going to be perpendicular to this line, and this line is parallel to this inclined plane. So it is pretty clear that this angle is going to be equal to phi. So in that case we can see that we have couple of expressions. Instead of ax equal to 0 and ay equal to minus t in the previous case, now your starting equations will be x equal to minus g sine theta. We put a minus sign because we have taken x-axis in this way and your acceleration is directed opposite way. So that's why we have a minus sign here. And exactly in a similar manner, we can have ay, which will be equal to your minus g cos phi. Again the minus sign comes because your component of acceleration is in the opposite sense of your y-axis.
So minus the sine phi.
This will be phi, sorry. This will be phi. So it is sine phi and then it will be cos phi. So now pretty simple, because your phi is constant, so it does not actually produce any hindrance to your result, and you can find out from here first Vx From here you can simultaneously find Vy, and from here you can simultaneously find X, and here you can simultaneously find Y. So all this can be done provided you know the initial conditions, and the initial conditions you may say at time t equal to 0, x is equal to 0, y equal to 0, and Vx equal to u0 cos theta 0 plus, and Vy is equal to plus u0 sin theta 0. So these initial conditions you need to take into account, and thereby you can find out the thing. Now to find out the distance where it comes and hits this on the plane, simply make your this y, whatever y you are getting here, simply set y equal to 0, because at this point, you see this point, it is having the coordinates r comma 0. So you can therefore, whatever y you have found from this, by integrating, if you set this y equal to 0 there, then you will be getting the time when the particle comes and hits this, and then that time if you take and put it into the expression for x of t, you will be getting the distance r. I think you should do it at your home. I leave it to you as a homework.
Yes, sir. Yes, sir.
Okay, sir. Okay, sir.
Okay, you leave it to this. I leave it to you as a homework. You
Yes,
can,
sir.
you can do it at your home and come out with an expression how your r is, for this, what will be your expression for r. Correct. And if you reverse your problem, that means in this case the projectile is thrown up the plane. What will be the scenario if your projectile is thrown down the plane? So both the problems you can solve and find out your results. Plus you can solve some of the problems from your from this book, where you see this type of projectile problems are provided in your case. So you know all these here, majority of the problems are in fact actually projectile, and here I say that there are two types of problems every chapter, as you might have seen in your earlier statics also. You have some introductory problems and you have some representative problems. Now it will be my advice, because there are so many problems and so many chapters, if you start solving each and every problem from the chapter, you will not be able to cope pace, able to keep pace with the progress of the class, and then your development will be hampered. So my advice will be then what? Solve few problems in the introductory sections. Few means, say for your capacity, I mean to say for your confidence building, I may say you solve 5 problems from the introductory, not consecutive 5 problems. Initial 1 or 2, in middle 1 or 2, and at the end of the introductory problem 1 or 2. So that way you can take the problem 6. Okay, let's take first few 2 problems, middle 2 problems, and end of introductory 2 problems. And for the representative problems, which are little bit tough, I limit here, say for to start with, I say that you solve 4 problems from this representative section. And what will be the 4 problems? From initial, say 1 or 2, in the middle 1, and at the end 1. So take this, as your initial, the work. Of course, when you come back for revision, you may start solving of the unsolved problems at your first.
কিছু শোনা যাচ্ছে না
হ্যালো
স্যার?
স্যার। স্যার আপনি কিছু বলছেন কি? ওটা শুনতে পাচ্ছি না আমরা।
স্যার ক্লিচ করছে আবার।
মাই গড।
গ্লিচ বলে না, এটাকে ফ্রিজ বলে।
এই পরে স্যার।
ভাই আমার প্রেজেন্টটা কেউ দিয়ে দিস, ঠিক আছে?
কেন, কোথায় যাচ্ছিস তুই? স্যার ইয়েতে প্রেজেন্ট নেই, যতজন থাকে ততজনকে এক্সট্রা
এটা কি হলো অনির্বাণ?
স্যার মিটিং লেট করে দিয়েছে।
দাঁড়া রেকর্ডিং হচ্ছে স্যার, আবার জয়েন ইন করবে, আই গেস ওনার নেটওয়ার্ক ইস্যু হচ্ছে অনেক আজকে। রতেশ ভাই অডিও অন হচ্ছে কেন?
কেউ কথা বলবে না নাকি?
না। সব ঠিক আছে রে, দাঁড়া।
ওকে, আমি এখন অ্যাটেন্ডেন্স নিচ্ছি, ঠিক আছে?
একটা কাজ কর না, আমরা অ্যাটেন্ডেন্সটা দিয়ে দিচ্ছি, তুই সেটাকে কাট কপি পেস্ট কর।
না হলে এখন স্ক্রিনশট নিয়ে নে না, যারা যারা আছে।
ওটাই
যে
করছি,
কোনো একটা
একটু
বেছে।
wait কর।
হ্যাঁ হ্যাঁ, whichever suits you.
ওকে, এভরিওয়ান ক্যান লিভ নাও, ঠিক আছে? আর স্যার যেভাবে করতে বলেছেন ওভাবে করতে থাক, ব্যাস। এতটুকুই
আর
ছিল অ্যাকচুয়ালি। আর এখনই
হ্যাঁ
স্যারের
হ্যাঁ,
আর কি নেটটা চলে গেল, আর কিছু বলার ছিল না স্যারের।
আর
So,
রেকর্ডিংটা
you
থাকবে।
all can
চ্যাট
leave now.
বক্সে অ্যাটেন্ডেন্স দিয়ে দেবো?
না
না
না, আমি
নিয়ে
নিয়ে
নিয়েছি।
নিয়েছি।